Hello, my beautiful AP Computer Science students. Welcome to our very first lesson in our very first unit of AP Computer Science A. I'm Goldie, and I'm going to be taking you through this lesson today. It's in Unit 1, which is all about using objects and methods, and this lesson is just an introduction into Java. Just kind of the basics of the language. We're going to be looking at the sequencing, the program, what it looks like, and just talk about the compiler's role in catching errors and all of that good stuff. So welcome. I'm so glad you're along for this journey. Before we get to the first slide, I do want to talk a little bit about why we chose Java for this computing language. We've been using Java in this course since 2004, which seems forever ago now. But why are we choosing Java for this course? This course, AP CSA, is all in Java. We're going to be learning about all of the programming basics, all centered around Java. And really the main reason is that it's widely used. Of course, other programming languages are popular depending on your area of expertise, right? Whatever field you go into, you will be using some form of programming, and usually you do have a specific language set to whatever field requires it. But Java is very universal in the fact that it is used in a lot of those places. So we use Java both historically and just because it's so popular. It is an easy to learn language. There's very specific structure that needs to happen in a Java program in order for it to run. So you do have a beginner-friendly language with a lot of structure that is nice as a beginner programmer to have that structure. And then lastly, it's just so easy to run anywhere. So many platforms do run Java, and even if they don't, the skills that you learn in this course through Java are going to be applicable to any programming language you run into. So that's kind of my spiel on Java, and let's go ahead and see exactly what a Java program looks like. Let's look at your first Java program here. Woo, there it is. So I have a box that says code and console here. So the code is what you're actually going to be putting into your IDE. Now I say IDE. IDE stands for Integrated Development Environment, and that's where you're actually going to be writing your code. And when you write your code in your IDE, it might be, for us in my class, it's going to be a web-based IDE, which means that you are going to go to your browser like Chrome, and you're going to actually code in the web browser. And then the console over there on the other side, that is what's going to be displayed to the screen. Now, of course, when you run a program, you can have programs display things, you can have clickables in your program, images, sound, all of that stuff. In our course, we're just going to look at displaying items because we're learning the basics, right? So when you see console, we're talking about what is printed to the screen. So over on the code side, this is what we call Java source code. And this is actually what you as the programmer are going to be coding in. The line numbers over there, you see line numbers 1 through 6. Those are for reference only. So your IDE will put those in. You actually don't code those. What you do code is everything to the right of those colons. All of the characters you see there. That's your Java source code, and that's what we're going to be coding in. And like I said, the console refers to what is printed on the screen when the program is in the process of running. Okay. Here's what it might look like in your IDE. So in our IDE that we use in the web-based browser, our Java source code looks like this to the left here. You can see that certain words are going to be a different color. And this is just due to the different status of those keywords that we're going to be talking about in the next couple of lessons here. So it's nice when your IDE does have those colors because it just helps organize your code that much better for you visually. And then the console, sometimes your console is going to look different depending on what IDE you use, but it will display some text in a text box of some kind. So let's break down this code that we have, our very first program. So line 1 here that I have highlighted defines what's called a class. And every Java program starts with at least one class. For us, we're going to start with just example. Okay. Each class has a name, example in our case, and it must start with an uppercase letter. So all classes have to start with an uppercase letter. Our classes will always start with public. We'll explain, of course, what public and private and all of those mean a little bit later on, but our starting classes will always start with public. And then we start with the word class, and then example is what I call it. In our program, the class name is example. But you can call it anything. And that is going to be the first line of code that defines your class. You see at the end there, I have that open curly bracket, and we're going to talk a little bit more about what that means. But that's going to define my first line of your class. So your first line in your Java program will look like this. Line number 2 defines what the main method, what we call the main method. So all Java programs execute from the main method only. Okay. So you as a programmer are going to eventually make many methods and potentially many classes, but the main method, there's only one main method, and it's the only one that executes. So I say we have this main method here. So you see, this is the word main, okay? One main method per program, and all of those keywords that you see there should be part of your main method signature. Now, you don't know what these keywords mean, right? We have public static void, we have our word main, and then in parentheses, we have this jumble of things and symbols. Again, we're going to know eventually what all of those things stand for. But for right now, just know and accept that those have to be part of your main method signature in order for the program to run. Okay. Line 3 is what we call a comment. So comments are put into the program to help programmers communicate their program to other programmers as well as to their self. And comments themselves are totally optional in a program, but I highly encourage you to put them in. So line 3, you see I say displays to the screen. Now those 2 slashes, those are called a line comment, which means that anything, once you put that in, that's a symbol for the program to ignore the rest of this line, okay? So the rest of that line is not actually going to be run by the program ever. It is just for the programmer themselves to see. Okay. We also have what's called a block comment, and that uses another special type of symbol, a slash with a star, and then the end of the comment is a star, then a slash. Now that's called a block comment because anything between those 2 symbols is going to be ignored by the program as it's running. So again, you can make a bunch of comments in there, type whatever you want, as long as it starts and ends with those symbols, then it's going to ignore everything. And I have a little example of a block comment here. So I have public class example. You see my main method signature. Again, just accept all of those words. You need them to make your program run. And then lines 3 through 5 here, this is an example of a block comment. So you see how I start and end with that block comment symbol, and everything in here, all of this text is going to be ignored when my program is run. Okay? That's a block comment. Comments are not required in the program. Again, they're totally optional. They are there for you as the programmer to help organize your code. Okay? And then let's get to line number 4. Line 4 is what's called a statement. This statement uses a method to display what's called a string literal. So that code system.out.print, and this is LN. Okay, we call this together system.out.print line is what we pronounce that as. And what it means is you're going to print to the screen whatever is in parentheses there. Okay. Now, what's in the parentheses is what we call a string literal. And a string literal is a sequence of characters that are closed inside the quotations there. Okay. So not enclosed in parentheses, it's enclosed in quotation marks there. Okay. Now, the system.out.print line uses the parentheses, but the string literal itself is going to be enclosed in those quotation marks. And then at the end of that, we have a semicolon. Every statement in Java is going to end in a semicolon. And that's very specific. Different languages, some languages do it, some languages don't do it. For us in Java, we always end statements with a semicolon. Okay. So that's your very first program. Okay. If you wanted to put that in your IDE and see it run, okay, when you go to run it, it's going to display welcome to AP CSA. Now let's talk about those special characters that I briefly mentioned as we went through that first program. So the first one is open and close braces. I call them curly braces or curly brackets, but they form what we call a block, like a visual block. Each block will begin with an open brace and end with a closed brace. And in that example we just did, we have a class block and a method block. So all the classes you create are going to have the curly braces for the open and closed block. And then the methods are all going to have an open and closed curly brace for the block of methods. Okay, so think of them as like blocking off segments of code. You're organizing code in essentially blocks or boxes. Now, what you saw in the main method signature, you saw these square brackets. So open and closed square brackets. These create an array. Okay. Now, you don't know what an array is yet. We'll learn about it later, trust me. But that is a special character reserved specifically for arrays. Now, parentheses, open and close parentheses, they have multiple uses in a program. In the code we just saw, they're used with our methods. So it's used with our main method, but it's also used with our method call from system.out.println. Okay. The double slash denotes a line comment, and everything on that line after the double slash is ignored by the program and will only be seen by the programmer themselves. The semicolon marks the end of a statement, and it is required for the end of every statement. We didn't include it at the end of every line, so that's important. It's not at the end of every line, it's at the end of every statement that we have. Okay. So all of this to say, Java has its very own syntax rules. You have to write the code in a way that conforms to these special characters and the formats that we're just starting to talk about. If you violate a syntax rule or you don't include it, you don't follow the rules, you'll get what's called a compiler error. Okay? And when you get a compiler error, that means that the compiler cannot translate your code into machine language. When we code as programmers, we are programming in not a computer language necessarily. A computer only understands binary, right? They only know ones and zeros because a computer is made up of electrical signals. So in order for the computer to understand your directions, what is happening behind the scenes, we're taking your programming language and we're translating it into this machine language. Now, translating it with a translator, that translator is called a compiler. Now, in order to successfully translate it, you have to make sure that you follow those syntax rules. And if you don't follow those syntax rules, the translation can't happen correctly. Okay? So here's kind of that process. Now, you are going to write your source code in the Java programming language. And then the next step, when you actually go to run your program, what you have to do first is what's called compile, and that's translate your source code into machine code, into language that the computer can understand. Now, there's a lot of nuance that goes into that step, but we're not going to get directly into that in this course. But just know, basically, you're translating source code into a machine code, okay? And then you can run your Java program. Now, the IDE that you are using does this differently depending on what IDE you use, okay? So in our web-based one that we use, when we click the button called Run at the top, it is going to compile and run all at once. So it's going to compile first and then run. It's like one step for you as the programmer. You just click a button and it compiles and runs. On other IDEs, especially IDEs based on your computer and not in the web, usually it's a two-step process. Usually you have to push compile first and that creates the machine code file, and then you run that file. So a lot of times that's a two-step process. So it just depends on which IDE you are using. But no matter which IDE you use, it will always compile first and then it'll run. Okay? Whether that happens in one step or two just depends. Okay. Now let's talk a little bit more about errors that can occur in a program. So I've already briefly talked about syntax and how we have the syntax rules that need to be followed in our program. You can have a syntax error, and a syntax error would be a mistake in the program rules where the rules are not followed. Some examples might be missing some of those special characters like a semicolon or a bracket. Sometimes it's misspelled words. It's just you left something off or you added something in that doesn't follow the syntax. And these types of errors are caught by the compiler. So your source code is compiled first before it is run. So in that process of trying to translate it into machine language, the compiler will catch that mistake and alert you. Okay, so your program will never run. It'll alert you to that syntax error first. The next type of error is what's called a logic error. And this happens when you have a program that can run, but it doesn't behave like you expect it to behave. There's something that happens unexpectedly or incorrectly and it's just not what you wanted out of your program. And some ways this happens might be flawed reasoning, misplaced boundaries in loops, what we call an off by one error. Something happened in your program, even though the rules were followed, logically it just didn't make sense for what you wanted it to do. And we're going to run into these a little bit more throughout the course. Not necessarily right now because we're just learning the basic syntax, but logic errors happen. Your program will compile fine and it'll run, but it just won't behave like you expect it to behave. The solution for these is usually to test the program with different inputs or different types of data to figure out where the error is occurring. Okay. The next is what's called a runtime error. And this is a mistake in the program where something happens during the execution that causes your program to crash in some way. An infinite loop, a stack overflow, out of memory in some way. Your program compiles fine, so all the syntax is followed, but during the running of your program, something happens and it causes it to crash. These errors cause the program to end abnormally. There's going to be some weird way that it ends, and you'll want to fix it in your program. Now, an exception is a specific type of runtime error. It occurs as the result of an unexpected error in your program, but you can predict when it might happen and you can handle it in your program. Okay, so an exception is a specific type of runtime error. Now, there's different types of exceptions. There's actually quite a bit of exceptions. Some of the common ones you're going to see in our course are an arithmetic exception, a null pointer exception, or an IO, an input-output exception. And the solution here is actually one that we're not going to cover in this course, maybe in an extended topic I'll have, but a solution for an exception is to use a try and a catch block to handle them if they come up in your program. Another way to handle exceptions is just to avoid them, right? So a specific type of arithmetic exception we're going to run into in the next couple lessons is divide by zero. So you know, as great students that you are, that you can't divide by zero. It's not allowed in math, right? It's a faux pas, as you say. And if you try to divide by zero in your program, you will crash your program. It'll compile fine, but your program will crash. Now, how do we handle that? Well, we know it could occur. So there is an exception that called an arithmetic exception that can predict when it's going to happen. But you guys as beginner programmers aren't going to handle those exceptions. What you're going to do instead is just avoid them, right? You're going to skirt around them. You're going to make sure that you write your program in a way that you'll never divide by zero. And I'll explain what that looks like in the next couple lessons. But those are the basic types of errors here. We have the syntax, the runtime, and the logical errors. And the exception is a specific type of runtime error. Okay. So let's talk about styling, okay? Good style makes it easy for both yourself as the programmer and others, like the teacher, to read, okay? We want to make sure that when we are styling, we're aligning blocks of code, aligning brackets, aligning words, tabbing correctly, all of that for easy readability. In the Java programming language, we actually do ignore white space. So tabs and new lines are purely for readability. Now, that's not the case in all programming languages. Like Python, for example, tabs and new lines are very important for the program to function correctly. For us in Java, not so much. So for example, our first program could have looked like this, right? So you see all of those words, you see them all kind of pushed together, and it's just kind of very hard to see. Can you imagine if I showed you this as our first program, how intimidating this might look, okay? But it's actually a very valid program. It follows all the syntax. But the way I presented it to you first was an example of good styling, where things were aligned correctly and indented to make it easy to read. Okay. Another way to kind of visualize good styling is, like I said before, with blocks, okay? Especially with those curly brackets. Those curly brackets really define the block. So in purple there, you see we have public class, and then that blank line, you can put any capital noun that you need to create your class, okay? And inside that purple block is a green block. That's your main method. And inside your main method, you're gonna have different statements, and all of your statements end with those semicolons. Now, the organization of this, you're gonna have tabs over, okay? So public class, that starts right like as you're typing, right? But then your main, you're gonna wanna tab over. And then your statement, you're gonna wanna tab over from there, okay? And that just promotes good readability in your program, both for you and for anyone who might be reading your program. You want to get in the habit of having good readability and good style right out of the gate here as you're learning your programming, okay? Here's the last thing I'll say about styling, okay? There's two popular styles when it comes to blocking. And actually, each of these is considered good programming style. This is one of those cases where it's really up to you and up to your personal preference. So throughout the course, I'm going to be using my own specific programming style. I'll try to draw attention to where other people might use different styles, but it's still considered good programming style. Here's an example of that, what we call next line style and end of line style. So next line style is actually what you see on the AP exam a lot. And what that is the curly braces, the curly braces are on their own line. Okay, so we have public class example here, and you see the open brace is on its own line and the closed brace is on its own line. And then in the main method here, you have your main method, it's tabbed over, and then the main method has open and closed brace on their own line as well, okay? And then the line comment is on its own line, and then the statement is on its own line. That's what's called next line style, and it does help if you like this. I feel like it does help visualize those blocks a little bit more, right? Because we have to have a method inside of a class. Our class is like the outside block. And then our main method, any method, has to go inside a class, like an inside block. And so next line style really does help with that, okay? Open and closed bracket are each on their own line. Now, another good programming style, and this is actually what I use a lot just because it takes up less space, and honestly, I'm just used to it, is called end of line style. And that's where the open brace is at the end of the line, okay? So for me, this takes up less space. It's less visual clutter in my mind. It's still considered good programming style, and it still for me, allows me to see the block, right? The class block and then the main method block, okay? But end of line style puts that open bracket at the end of the line, but the closed bracket is on its own line there, okay? That's end of line style. So throughout I'll probably use a mixture of both, honestly, because the AP exam does use next line style a lot. But for readability, I do also use end of line style. So you'll see a mixture of both throughout the course. Okay. But good styling is very important, and we'll be talking about that throughout the lessons. But speaking of lessons, that's actually the end of this lesson for us. We got through the first lesson of the first unit unscathed here. So thank you guys so much for following along. If you enjoyed this video, please click the like button, and you can also subscribe to my YouTube channel for more computer science content. Until then, I will see you in the next video. Thank you guys so much for watching.